Welcome to the another session in Frontiers in Safety. So today we are visualizing the fluid flow simulation for heat transfer in a 3D circular pipe using ANSYS Fluent. So the first objective is preparation of geometry for 3D circular pipe, then generate mesh and name selection so that it will be useful for applying the boundary condition in the setup. So we are applying the boundary condition setup in terms of two parameters. One it is velocity and second one it is temperature. So welcome you all. Today we will see the fluid flow simulation for heat transfer in a 3D circular pipe. So for this we were using ANSYS 2023 release 1. In the workbench window we are going to make use of the fluid flow Fluent. So once this window is open, so click on fluid flow Fluent. So let's go with the first preparation of geometry with the help of new design modeler. So we are going to set the units first. Let's say centimeter. So we are dealing with the fluid flow simulation 3D for heat transfer. Fluid flow simulation for heat transfer in 3D circular pipe. So for this we need to create a pipe first. Let's take a primitive cylinder. Let's make it frozen. Let's say the component where you want. I want it to be in X direction. Say around 150. Okay, Z component is 0. Let's make the radius is equal to 5. So this is the one pipe which we have prepared. So let's generate the pipe. So this is now as a solid pipe. So we can make this pipe as a hollow. Let's make it thin surface. Yes, okay, I will specify thickness as 0.5 and let's generate. So this is a pipe which is generated. So this is a hollow pipe through which the fluid is likely to flow. Now we have generated the pipe. Now it's time to specify the fluid zone because the computer will not understand where is the pipe, where is the fluid. So we need to specify the fluid zone. So let's take it, select all the internal faces. So only one is there. So make it generate. So now you will see two part, two bodies. Earlier it was one part, one body. Now this is a solid, that is the outer wall. You can see here solid also. But in second thing it is fluid, but it has specified the name as a solid. So we'll rename this as a fluid. You can specify the name where if the fluid you are using, let us suppose water. So you can specify there water also. So this is your solid and this is your fluid. So this one you can also specify as a pipe rather than specifying a solid. So this is a pipe and this is one fluid. Say if I say the water is flowing, so you can specify say water is also flowing. So accordingly things can be done. So this is the first thing which is related to the preparation of geometry in the design modeler. Now let's go to the workbench window, click on mesh. So now click see here pipe 1 it is showing solid and then water it's showing a fluid. So this is one thing which you need to carefully do before proceeding for your mesh. Now when you reach to the mesh, you may generate the mesh as a default mesh as of now first. Say this is one. If you want it somewhat fine, you can put it let's say 0.01 and let's make it generate. Check if whether it is finer than this or not. If you are not satisfied, you can put it let's say one more 0 and let's make it generate. So this will be finer, but again definitely the time required for the simulation and the time required for meshing will also be higher one if you are taken 0.001. So this also need to be taken into consideration when we are proceeding for any kind of simulation. So it is taking some time. We'll just wait. So we are taken 0.001. So sometimes if your configuration of the computer is not that good, uh, the system may get hang also. So be prepared with this. Yeah, now it is around 47%. So it will be too fine mesh 0.001. See the process during which the time required will be increased if we are taking it a finer mesh size. You can run with the default mesh size also and check the results whether they are in the proper way or not, and that later on you can come back to mesh and select the mesh size as per the requirement. So it is taking some time, so we have to wait. So you can see the RAM usage has significantly increased because of the finer mesh size. You need a better configuration computer also. Otherwise, if you are in your case, the system is getting lag. So you can click on this button and you can change the mesh size as per the requirement. Like in earlier case 0.01, it has generated quite easily. Now it is taking time, that is 0.001. So if it is not happening in your case, you can click on the red button, red symbol over here, and this will stop the mesh generation. But we will wait for some time. Okay, the mesh generation has done. You can see it is very fine. If you go with the number of nodes and element, it's too much, too high. So if you are using the student version, I recommended not to go with 0.001 because it is too small and your system also get lag. So what I will do is I will, instead of 0.001, I will put it 0.005 because this may take some longer time for generation and further for the simulation work. So I have taken 0. Here it is 0.005. You can see it is comparatively fine. You can see it is 2,47,952. So if you are using the student version, it is limited to 5,12,000. So if it is, I take it 0.00, let us say 3, and just check it how the mesh is generate. So higher number of nodes and element, that will result in more accurate result. Yeah, it is 8,86,588. So I go with this particular mesh because it has took less time also and a comparatively more number of nodes and element. Now it's time to specify the boundary conditions over here. So first of all, this is your pipe wall. So here it is pipe wall. Sorry, not inlet. It is to be renamed as pipe wall. Okay, now next is this one. So specify this as an inlet. Specify this as a outlet. So let's make it update. So we have specified three boundary conditions: one pipe wall, inlet and outlet. You will see one message: mesh translation to Fluent was successful. So this is your pipe wall, this is inlet, and this is your outlet on the other side. So accordingly you have to proceed. So once this is done, you can close the mesh window. So let's open with the next part that is related to your setup. So in setup we will be applying the boundary conditions. Now again, depends on how many processors you have on your computer. You can see select 10, 12, 4. Student version of, if you are using the student version of ANSYS, it is limited to only 4. So let's put the boundary conditions one by one. We need to specify the material also, which fluid we are using, because earlier we have specified water there, but we say we need to specify in the Fluent database which working fluid we are using. So you can see the arrows here, inlet and outlet. So let's first go with the gravity over here. So I will put it minus 9.81. We are doing with the heat transfer for fluid flow in a 3D circular pipe. So that's why I have put it transient mode, because there will be variation with respect to temperature. So energy equation I will turn it on over here, make it okay. Here I will put it K epsilon, because there are the specific options are available like enhanced wall treatment, thermal effect and curvature correction. In another model there is, these are options are not available, so that's why we have selected the K epsilon model. Okay, now next thing is in the model we have done. Now we need to specify the fluid. So use the Fluent database over here and select the water liquid, which is extremely at the bottom. Make it copy and close. So close this. So you can specify the material for your pipe. I make select this a different material also, like from the Fluent database. Just go here as solid, and you can select any of the material which is over there. But I'm not selecting it. I'm keeping the aluminum as it is, not in with this particular case. Okay. Now next thing is your boundary conditions. So where we are going to apply the boundary conditions, we are going to apply the boundary conditions on the inlet. So let's say velocity magnitude is 0.5 meter per second. Make it apply and then close. Then we are going to apply the boundary conditions at the pipe wall, because it is the one where the heat transfer is subjected. So let's say around 50 degrees Celsius we are applying, and make it okay. Close one. Sorry, just a minute. Here, yeah, by default it is aluminum, but if you are using a different material, you have to select that respective material. Now by default we have selected aluminum, and only one solid was specified over, so that's why we don't need to worry about it. But if you are using different materials, you have to drop down this and select the required option. Okay, now next thing is we are done with the inlet, we are done with the pipe wall. Now go to the reference values, tell the computer from where to start. Say we are starting from the inlet, so let's say water over here. Then go to the initialization. Here take it standard initialization. Let's make it compute from inlet and click on initialize. So we are not dealing with any kind of phases over here, so that's why I'm not going to patch anything out here. So calculation activities, if you want to save the work, or sometimes the problem occurs, so after every time step the work will be saved. Solution animation, you can put it or you can keep it also. Like say for example I want to see the temperatures. I want to see the total temperature over here. So let's select it all and make it apply. Now one thing you are observing over here is the exponential scale. I don't want the exponential scale. I will make it float, and you will see a scale which is better. So let's take it, make it okay, and click on save display, and then you can close it. So we have selected the wall temperature over here, and that visualization will be having. Okay, now next thing is you can directly jump to your thing, this number of time step over here itself. But there is one important thing is that whatever you have done is whether it is going in the right way or not. So that is one way of checking it. So we'll go with the graphics over here. So see the path line. So particle variable, I will select temperature, and let us say this is the total temperature which you are observing. Select all and just observe on the left hand side. Save display if I put, and once this is save display, I will show you one thing which is the important to check whatever we did is in the right way or not. Just wait for some time. As we have taken a very fine mesh, so that's why it is taking some time. uh, so if you want to see the pulse, that is also definitely going to take more time. So just let's have a visualization for it. So you can see the track of particle here which is proceeding forward. Okay, click on the stop button. Once this is stop, you can visualize. Okay, now one more thing which we can visualize is the velocity. So velocity magnet here. So I selected save display, and I will click on pulse also again. So there you will be able to visualize the velocity. That is means the track which is the fluid particles are following, that we are able to visualize it. So again it will take some time. So this is the pulse. If you click on it, you will see the path of individual fluid particle. So you can see the path of individual particle here, how the fluid is advancing forward. So this is the way in order to check whether you are done is in the right way or not. I will stop this. It will still again take some time. Okay. Now let's go to the run calculation here. I will put it 500 one time step and let's start the calculation. We have took very fine mesh, so that's why the time required is more. You can proceed with a smaller mesh size. That will help us to reduce the time required for your simulation. You can see the color contour also here at the same time when the simulation is been running. So that is one way of to predict whether we are going in the right way or not. So velocity magnitude is, you can also specify. So once this is completed, you will see your message as calculation complete, and once that message is received, you can go to the last step, that is the in case of your result. So we'll wait till the time the calculation is complete. Okay, the calculation complete message is received, so you can click on OK. Now you see this is in front of everything is right click. So if you want to save the work file, you can save it, say here. So you can create a separate folder. Okay. Okay, so we are having the fluid flow simulation for heat transfer in a 3D circular pipe. So for this we are going. Once this is saved, you can go back to your workbench window and okay, so it is saved. Now we can go back to Fluent window, click on close Fluent. Now go to the last part, that is result, click on edit. So we have took a very fine mesh, so that's why it's taking time. You may proceed with a comparatively lower mesh size for this. So first of all, pipe wall, let's specify here 0.9, make it apply. Then inlet, specify 0.9, make it apply. And then your outlet, make it 0.9 and then apply. So this is the first thing. Now let's go with the streamline which we are interested in. So click on streamline here. So from where to start, that we need to specify inlet. here. I will change the component is the variable that is related to temperature here. So go back to your geometry. This is number of points I will specify. Let us say for example 50. Click on apply. So this is a temperature streamline. If you want to change the legend to say instead of scientific you can make it fixed also. So you can see this how the temperature variations are there. You can see the scale also here. I will put it like this. So this is quite better visualization. In addition, you may increase the number of points also here. Say for example 100. Again, the rendering will require more time as per the, you can say, the mesh size which we took. So here you select sweep animation, go to the streamline, take it somewhat slow so as to visualize it in better way. And let's see the particles. So right now we are taken larger size of particle over here. So we are run it only for around 500 times here. So that's why we are not able to see visualize a temperature in quite detail. So do one thing. We'll reduce the size of particle here. So go here, go to the options. Symbol size we are reducing. Let us say to around 0.42, half of the earlier one. Make it apply and just one more time visualize. So the particle size has reduced over here. So you can see the change in the color contour for the particle. That means when the fluid is flowing, it is taking heat from the wall. So let's stop it. Now let's visualize. So this is all about the visualization which is taking place in terms of color contour. How actually the variations are taking place in terms of temperature, that we are going to see. For this we need to prepare one line. So I will create a line over here. So make it apply. This one. Okay, so first point and last point that we need to understand. So we took around 150 centimeter, I guess. So 0.150. So just see. Okay, just a minute. I will close the contour so that to visualize. Okay, so this is a line which is okay 1.5 I will take because we are taken 150 centimeters. So this is from end to end, from the start to end. So this is a line which you have drawn. Now let's go to the chart option here. Click on this data series. So here location I will put it line also you can put. Streamline if you take it will also generate result, but it will be for n number of particles. So x-axis I want it to be the x, y-axis I want it to be temperature. So click on temperature and just click on apply. So you will see this is 0, that is inlet, and this is your outlet. So how the variations are temperature taking place from inlet to outlet. So this is for individual line which you have specified. So as you say here, for this line how the temperature variations are taking place, so that is when visualize over here. So this is temperature with respect to the distance in x direction, because our component was in x. So that's why we took this line as 0 and 1.5, because it was 150 centimeter. So 1.5 we are taken. So this is how the visualization that can be done. Instead, if like in charts, if you go with okay, if you go with the charts, and right now what we did is we took line 1. Instead, if you select streamline, you will see the temperature of individual particle. So n number of we can say particles will be there. So initially some of the particles also have higher temperature, so they are considered to the particles which are near to the wall, and which are at the center we have comparatively lower temperature. The line which you have drawn, it was at the center, so that's why it shows the particle which are at the center. So that's why initially it is quite less value, then later on the temperature is increased. So for streamlines you can see the temperature of each and every individual particle. So whatever the number of particles we have specified, so accordingly it will show the temperature. So initially why it shows higher temperature, it is because some of the particles are near to the wall, and that's why it is showing the higher temperature. So let's one more time, let's go for the visualization again. This is one thing. If you want to save the movie, you can click on save, and you can save with respect to the resolution which you want, like HD 1080p. You can save with the image file also over here, and then You can see save as image file, as well as you can save it to the highest number of frames also. So let's take a last look of the visualization over here. Sorry, don't save, click on this. So this will be saved in we can say document folder. So let's have one more visualization for the particles which are moving. So the color contours of the particle is changed, especially those who are near to the wall, they are changing quite earlier than those who are at the center. So in this way we can plot the chart also for any the temperature distribution which is taking place through this we can say for streamline as well as for a line. Okay, that's it for today's session.